Hi guys, Assalamualaikum. My name is Syamilah Atirah Binti Hassan. So now I am going to present sunset and twilight. Have you heard about sunset? Do you know what sunset is? Let's see. Sunset, also known as sundown, is the daily disappearance of the sun below the horizon due to Earth's rotation. So, are you guys curious how the sunset happens? Okay, like this, let me explain. The sun stays in its position at the center of our solar system. It doesn't move at all. It doesn't rise, it doesn't set, but it appears to rise and set because of the Earth's rotation on its axis. Okay, as we know that Earth rotates on its axis, it makes one complete turn every 24 hours. It turns towards the east, so that's why we always say that the sun rises on the east and the sun set on the west because of the Earth's rotation from east to west. Do you know why when the sunset happens, the colors of the sky turns red or orange? Have you ever thought about that? So this is the answer. As a ray of white sunlight travels through the atmosphere to an observer, some of the colors are scattered out of the beam by air molecules and airborne particles, changing the final color of the beam the viewer sees. Sunset is really beautiful, especially when the sky turns red and orange and sometimes pinkish and sometimes purple, but beware, keep your eyes safe. So, we have to use binoculars, sometimes telescope or a telephoto lens to protect our eyes. Remember, be safe everyone. Next is Twilight. When I say Twilight, you must think about the vampire, which the main actor is Edward Cullen and the main actress is Bella Swan. No, this is not that Twilight. This is another Twilight. So, what exactly is twilight? Twilight is the time of day between daylight and darkness, whether that's after sunset or before sunrise. It's a time when the light from the sky appears diffuse and often pinkish. The sun is below the horizon, but its rays are scattered by Earth's atmosphere to create the colors of twilight. Do you know that there are three types of twilight? First, civil twilight, second, nautical twilight, and third, astronomical twilight. Civil twilight. Civil twilight is when sun is up to 6 degrees below the horizon. Next, nautical twilight. Nautical twilight is when sun is 6 to 12 degrees below the horizon. And the last one is astronomical twilight, which is when sun is 12 to 18 degrees below the horizon. So during the civil twilight, you still can see the sky has orange color. This is because the sun is just 6 degrees below the horizon. So during the nautical twilight, you cannot see the orange light anymore because the sun has gone down to 6 to 12 degrees below the horizon. So the last one is astronomical twilight, where you cannot see any orange light anymore because the sky has gotten darker and darker, and soon it will become night sky.
Assalamualaikum and hi everyone. My name is Syafiqah binti Sorhaimi. Today I'm going to present about evening sky, or we can call it as night sky. So shall we start now? Let's go! First of all, I would explain about what is night sky. So basically, night sky refers to the nighttime appearance of celestial objects, which means objek-objek yang ada di cakrawala, such as stars, planets, and moons, which are visible in a clear sky between sunset and sunrise when the sun is below the horizon. Second, I will explain about the brightness of night sky. Sky brightness is the visual perceptions of the sky and how it scatters and diffuses, maksudnya menyebarkan, light, cahaya throughout the whole night. Actually, the sky is not completely dark at night, even in the absence of moonlight, natural light, or city lights. It can be easily observed because if the sky were dark, people will not be able to see the silhouette or bayangan of an object against the sky. For this slide, I just want to show you guys the big picture of natural light sources in the night sky. We have starlight, moonlight, and aglow, and they are depending on location and also timing. Third, what do we see in the night sky from the Earth? A clear night sky offers an ever-changing display of fascinating objects to us to see the stars, the constellations, the bright planets, the moons, and sometimes special events like meteor. Next, are you guys wondering why we can see the celestial objects in the night sky? So everyone can take a look at the picture that I have attached for this slide as your imagination. We can see those objects because the Earth turns on this axis every 24 hours so that we can see the sun, the moon, the stars rise and set with clockwork regularity. If the Earth does not turn on this axis, we also cannot see the night time, and we only could see the daytime. So the celestial objects are not really on a dome of the sky, but at greatly varying distances from us in the space. So here is the example of night sky in Malaysia and Yosemite, California. Okay, this one is the example of night sky in North Pole for the first picture, and the second one is Dubai night sky. Okay, we almost reached the end of my presentation for today. So before that, I want to explain about what is an aurora night sky and how do aurora form. Aurora is a beautiful light shows in the sky and can be seen near to the North and South Pole night sky. Even though auroras are best seen at night, but they are actually caused by the sun. As you can see, the sun said, "Yeps, it's all because of me." So yes, the auroras form because of the sun. The sun sends us more than heat and light. It sends lots of other energy as well and small particles our way. However, the sun does not send the same amount of energy at all the time. There are constant streaming solar wind and there are also solar storms, or we call it as ribut matahari. So during one kind of these solar systems called a coronal mass ejection, the sun is going to burp out a huge bubble of electrified gas and it can travel through the space at high speeds. Therefore, when a solar storm or ribut matahari comes toward us, some of the energy and small particles can travel down the magnetic field lines at the north and south poles into the Earth's atmosphere. So, the particles will interact with gases in our atmosphere, resulting in beautiful displays of light in the sky, and the oxygen will give off the green and red light, the nitrogen will glow blue and purple. So, it formed the beautiful aurora. So here is the example of the aurora, because aurora has two types. If we are near to the North Pole, then it is called as an aurora borealis or northern lights. But if we are near to the South Pole, then it is called as aurora australis or the southern lights. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Nurul Fitri Binti Shaiful Jefri. Today, I will present about 4 seasons. There are 4 seasons, namely autumn, winter, spring, and summer. Not at all countries experience 4 seasons. For example, our own country, which is Malaysia. Autumn. Autumn, also known as fall in North American English, one of the 4 temperate seasons outside the tropics. Autumn marks the transition from summer to winter in September or March. The duration of daylight becomes noticeably shorter and the temperature cools considerably. Autumn autumn will take place on Tuesday, equivalent to 22nd September 2020 until 21st December 2020 on Monday. Next is winter. Winter is the coldest season of the year in polar and temperate zones. It occurs after autumn and before spring in each year. Winter will occur on Monday, 21st December 2020 until 20 March 2021 on Saturday. Next is spring. Spring, also known as springtime, one of the four temperate seasons succeeding winter and preceding summer. There are various technical definitions of spring, but local usage of the term varies according to local climate, cultures, and customs. Spring will take place on Saturday, 20 March 2021 until Monday, 21st June 2021. And the last one is summer. Summer is the hottest of the four temperate seasons, falling after spring and before autumn. At or around the summer solstice, the earliest sunrise and latest sunset occurs. The days are longest and the nights are shortest, with day length decreasing as the season progresses after the solstice. Summer will take place on Monday, 21st June 2021 until Thursday, 23rd September 2021. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hanna Binti Nazim, and today I will share about precession. What really is precession? But before that, do you know who and how precession discovered?
Pada zaman dahulu,
An astronomer named Hipparchus measured the longitude of Spica and then he compared with the data from his predecessors. From his observation and measurement, he concluded that Spica had moved by 2 degrees in the time span of 2 centuries. But how it happens? Now, I need you to imagine a spinning top. Not this one, but this one. Can you see how the spinning top wobbles and falls under gravity? The spinning top may complete a full rotation in just a few milliseconds, but it's not the case for Earth precession, as it takes 26,000 years to complete a rotation. The image of Earth you have in mind may be the perfect sphere, right? But it's not. The Earth are a little bit bulged on the side, and it tilted 23.5 degree. The rotational movement happens because of the gravitational impact of the moon and the sun that tug and twist the Earth to keep it upright on its axis. The wobbly movement of Earth happens, but what affected by it? The precessions affect the length of the year. There are 2 ways to measure the length of a year, and that is first the tropical and the second one the sidereal. In January, the sun is in the constellation Capricorn. Over a year, the Earth moves through all the signs of zodiac. Once Earth lands again on the Capricorn, we have completed one sidereal year. Different than sidereal, tropical did not depend on the Earth position. It depends on the Earth axis. When the North Pole faces away from the Sun, the Northern Hemisphere will experience the winter solstice. If two winter solstices had passed, you get one tropical year. Oh, looks like it's the end of my presentation. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraina Nadhilah and today I will present the next subtopic which is moon phases. As we know, the moon spins around the earth in its orbit and do not have its own light. The moonlight we see is actually the sun's light and this sunlight responsible for the moon transformation. When the sun and moon are aligned, we cannot see the moon as the side facing the earth does not get the sunlight and this we call as new moon. As the moon continues to orbit and move a little ahead after 2 or 3 days, some light from sun start to fall on some of its part which make the moon appear in a crescent shape. This phase called the waxing crescent. As the moon continues its orbital journey, the sun's reflection keeps on increasing on the moon's surface, and it is called half moon as we can see exactly 50% of the moon's surface illuminated. This called first quarter moon as the moment the moon has reached the first quarter of its orbit. In about 2 or 3 days, just after the first quarter moon, we can see that the moon is more than half full and still increasing its illuminated surface. In this phase, we call as waxing gibbous. When the moon reaches behind Earth, the full side of the moon facing the Earth get the sunlight, and finally we can see the full moon. As now comes the waning stage where the moon starts its return journey from full moon to the invisible new moon as the light begins to decrease on its surface, and this stage we call as waning gibbous phase. After this occurs, the last quarter phase is when the opposite half of the moon is illuminated compared to the first quarter. This is called third quarter moon as the moon has reached the third or last quarters of its orbit around the Earth. This is followed by the waning crescent phase in which the moon shrinks back to a crescent that's less than half full. And finally, the moon finishes its journey in about 29.5 days and comes back between the Earth and Sun to its new moon phase, marking the completion of the moon phase just to start over again.
Assalamualaikum. My name is Fatin Najihah Binti Mohamad Amin. Today I will explain about eclipse. An eclipse takes place when a celestial body is temporarily secured by another celestial body or by its shadow. An eclipse happens when a planet or a moon gets in the way of the sun's light. There are two types of eclipse. First, solar eclipse, and second, lunar eclipse. A solar eclipse occurs when the moon moves between the sun and earth. Sometimes, when the moon orbits earth, it moves between the sun and earth. When this happens, the moon blocks the light of the sun from reaching earth. This causes an eclipse of the sun or solar eclipse. During a solar eclipse, the moon casts a shadow onto earth. The picture shows the position of the sun, moon, and earth that occurs during a solar eclipse. As you can see, when the moon moves between the sun and earth, the moon casts a shadow onto earth. There are three types of solar eclipse. First, total solar eclipse. Second, partial solar eclipse. And annular eclipse. Total solar eclipse. A total solar eclipse is only visible from a small area on Earth. The people who see the total eclipse are in the center of the moon's shadow when it hits Earth. The sky becomes very dark as if it were night. For a total eclipse to take place, the sun, moon, and the earth must be in the direct line. Second, partial solar eclipse. This happens when the sun, moon, and the earth are not exactly lined up. the sun appears to have a dark shadow on only a small part of its surface. Third, an annular eclipse. An annular eclipse happens because the moon is farther away from Earth and it seems smaller. It does not block the entire view of the sun. The moon in the front of the sun looks like a dark disk on the top of the larger sun-colored disk. This creates what looks like a ring around the moon. During a solar eclipse, the moon casts two shadows on Earth. The first shadow is called the umbra. This shadow gets smaller as it reaches Earth. It is the dark center of the moon's shadow. People standing in the umbra will see a total eclipse. The second shadow is called the penumbra. The penumbra gets larger as it reaches Earth. People standing in the penumbra will see a partial eclipse. The moon moves in an orbit around Earth, and at the same time, Earth orbits the sun. Sometimes, Earth moves between the sun and the moon. When this happens, Earth blocks the sunlight that normally is reflected by the moon. Instead of light hitting the moon's surface, Earth's shadow falls on it. This is an eclipse of the moon, or a lunar eclipse. A lunar eclipse can occur only when the moon is full. This picture shows the position of sun, earth, and moon that occur during the lunar eclipse. Types of lunar eclipse. First, total lunar eclipse. A total lunar eclipse occurs when the moon and the sun are on exact opposite side of Earth. The sunlight passes through Earth's atmosphere, which causes Earth's atmosphere to filter out most of the blue light. This makes the moon appear red to people on Earth. Second, a partial lunar eclipse. A partial lunar eclipse happens when only a part of the moon enters Earth's shadow. In a partial eclipse, Earth's shadow appears very dark on the side of the moon facing Earth. What people see from Earth during a partial lunar eclipse depends on how the sun, Earth, and the moon are lined up.
Assalamualaikum and hi, my name is Sakinah Binti Zainal Abidin. Now I will explain to you guys about solar activities. Before we go through, let us look at some interesting facts about sun. Sun facts. The sun, as shown by the illustration at right, can be divided into 6 layers. From the center out, the layers of the sun are as follows. The solar interior composed of the core, the radioactive zone, and the convective zone. Then there is a visible surface known as the photosphere, the chromosphere, and finally, the outermost layer, the corona. What is solar activities? Some examples of solar activities are solar flare, coronal mass injection, high-speed solar wind, and solar energetic partial are all forms of solar activity. Next, solar flare. A solar flare is an instant burst of radiation coming from the release of magnetic energy associated with sunspot. Flare are our solar system's largest explosive event. We typically see a solar flare by the photons or light it releases at most every wavelength of the spectrum. The next solar activities is solar prominence. A solar prominence is a large bright feature extending outward from the sun's surface. The prominence plasma flows along a tangled and twisted structure of magnetic fields generated by the sun's internal dynamo. An erupting prominence occurs when such structures become unstable and burst outward, releasing the plasma. Coronal mass injection, or CME. A large CME can contain a billion tons of matter that can be accelerated to several million miles per hour in a spectacular explosion. CME are sometimes associated with flare but can occur independently. Next, coronal holes. Coronal holes are variable solar features that can last for weeks to months. These holes are rooted in large cells of unipolar magnetic field on the sun's surface. Their field lines extend far out into the solar system. This open field line allows a continuous outflow of high-speed solar wind. How strong is solar wind compared to wind on Earth? The solar wind is very weak compared to the wind on Earth, though it is much faster. When we measure solar wind speeds, we typically get speeds of 1 to 2 million miles per hour. They end up being weaker because there is very little of it.
My name is Nuraina. Now, I will continue regarding the solar activity. What is sunspot? Sunspots, dark areas on the solar surface, contain strong magnetic fields that are constantly shifting. A moderate-sized sunspot is about as large as the Earth. Sunspots form and dissipate over periods of days or weeks. They occur when strong magnetic fields emerge through the solar surface and allow the area to cool slightly from a background value of 6,000 degrees Celsius down to about 4,200 degrees Celsius. This area appears as a dark spot in contrast with the very bright photosphere of the Sun. The rotation of the sunspot can be seen on the solar surface. They take about 27 days to make a complete rotation as seen from Earth. Sunspots remain more or less in place on the Sun. Cycles are periodic variations or cycles of high and low activity that repeat approximately every 11 years on Sun. Although cycles as short as 9 years and as long as 14 years have been observed, the solar or sunspot cycle is a useful way to mark the changes in the Sun. What is solar minimum and solar maximum? Solar minimum refers to a period of several Earth years when the number of sunspots is lowest. The Sun may go many days with no sunspot visible, while solar maximum occurs in the years when sunspots are most numerous. During solar maximum, activity on the Sun and the effects of space weather on our terrestrial environment are high. At maximum, there may be several hundred sunspots on any day. Space weather to describe the dynamic conditions in the Earth's outer space environment. Weather and climate refer to conditions in Earth's lower atmosphere. Space weather includes any and all conditions and events on the Sun, in the solar wind, in near Earth space, and in our upper atmosphere that can affect spaceborne and ground-based technological system. The term space weather refers to the variable conditions on the Sun and in space that can influence the performance of technology used on Earth. Extreme space weather could potentially cause damage to critical infrastructure, especially the electrical grid. The Sun is the main source of space weather. Sudden bursts of plasma and magnetic structures from the Sun atmosphere, called coronal mass ejection, together with sudden bursts of radiation or solar flares, all cause space weather effects here on Earth. Space weather impact. Space weather can produce electromagnetic fields that induce extreme currents in wires, disrupting power lines, and even causing widespread blackouts. Severe space weather also produce solar energetic particles, which can damage satellites used for commercial communication, global positioning, intelligence gathering, and weather forecasting. Some real events of space weather impact are: on March 13, 1989, a powerful geomagnetic storm set off a major power blackout in Canada that left 6 million people without electricity for 9 hours. Secondly, Carrington event in September 1859, disruption of telegraph service. Space weather events being observed by scientists utilize a variety of ground and space-based sensor and imaging systems to view activity at various depths in the solar atmosphere. Telescopes are used to detect visible light, ultraviolet light, gamma rays, and X-ray. They use receiver and transmitter that detect the radio shock wave created when a CME crashes into the solar wind and produce a shock wave. In conclusion, does all solar activity impact Earth? Solar flares impact Earth only when they occur on the side of the Sun facing Earth, while coronal mass ejections only impact Earth when the cloud is aimed at Earth. CME will hit the Earth and can cause impacts. And lastly, solar wind. These holes can form anywhere on the Sun, and only when they are closer to the solar equator, the winds they produce impact.